all of the Agile methods began with the idea that we would have cross-functional and self-organizing teams. And I think if you go to any SAFe or Scrum shop, you'll find out that's the first thing they deleted before adopting.
ProCognita, Get Agile podcast.
Why Agile teams need extreme programming practices. Interview with Tim Ottinger. Hi, and welcome to Get Agile podcast. We are in ACE conference venue in Krakow, and I have a pleasure of talking with Tim Ottinger. You're one of few, I would say, in the world XP coaches, extreme programming coaches. A group of people who are not so popular, I would say, those days. And the whole European branch of industrial logic. So anything I should mention and I miss?
No, I think that's probably a pretty good start.
So let's get into this XP, or let's get into the engineering part of the XP. We are like 30 years of XP being alive. So the assumption somewhere, this is what I know, so the assumption is somewhere like everybody should know this by now. My observation is not so, and would like to start with this one. So where we are with the Agile engineering practices from your perspective?
So a lot of the extreme programming practices, they've continued. Nothing's happened to them. They're still there. Of course, when Scrum started to take, a lot of market share, they intentionally left out technical practices, and Schreiber Sutherland would say, well, to get hyper-productive teams, you need to have XP underneath it. And they would keep saying, you need XP.
And for some reason, no one heard this one.
Yeah, that's right.
For those of you who haven't been reading the history by now, it's like 20 years ago, Scrum wasn't the most popular framework. XP was the most popular framework, but it's changed for different reasons. Right?
Yeah. I think Scrum was more sellable, and they, of course, had a sales organization of paid people to promote it. So, nowadays, Scrum is being kind of eclipsed by SAFe. But the XP practices have still remained strong. We've always done working in groups. We used to do pair programming. Now we've all gone into ensemble, or teaming, I guess is the new name, where we work in groups. Test-driven has remained test-driven. It still is one of the best ways we know to incrementally build code that you can rely on and change. The code craft that came with XP has continued to develop. Sometimes it's not taken on the best reputation, but I think that we've come a long way with it. And the code that we craft today with our groups in TDD, I think is just miles ahead. But also, continuous integration was an idea from extreme programming. And we have taken that to just the nth degree. We have so much more continuous integration, and people are working in teams, integrating their ideas. We have the servers running, people, the code is daily builds. No, we're like minutely builds now. And CD has changed our world in XP. I don't know any XPs that aren't doing continuous deployment.
So it is alive. My question would be more like, how do you see it from like a worst perspective? It's like a standard. You mentioned a few of them. I know some of them are not the standard. So how do you see as a coach working with different companies? How do you see them as like what is a common understanding? What is a common practice? What is like we're not gonna do this here anyway kind of approach?
When we look at the companies that we get invited into, where we can observe, quite often we have people there who they've heard of pair programming or mob programming, one name or another for working in groups. And people there are saying, well, I would rather quit my job than actually work with other human beings. I only want this job so I can be all by myself. I can be all alone, doing my own thing.
The reason I finished engineering studies is not to talk to other people. This is okay.
And I think that there probably was a time that was almost acceptable.
But that was like 60s?
Yeah, maybe. Yeah, I think by the middle of the 80s, I started in 79, and by the mid 80s, we were always working in teams. So the idea that you could just sit by yourself and code, I think that's okay if you're starting your own open source project for the first couple years, but in general, I don't think it's a viable way of working.
And still it's I would say, commonly accepted. I mean, every company calls group of people team, but they hardly work as a team, right? So
that's right. What we see, by the way, isn't even Scrum. What we tend to see in the wild is something I call solo ticket processing.
With micromanagement on daily basis.
That's right. So we're going to go Agile. By Agile, what I mean is I'm going to put pressure on you.
And install some tool for you to report those tickets on me.
That's right. And so your job is, here's your 2 weeks worth of tickets to be done within 2 weeks. And by the way, it might take longer, but you need to get it done in 2 weeks. And if you have to do overtime, that's okay, as in do overtime. And you each do your own work and don't communicate. Well, that was never part of Scrum. It was never part of XP. It was never part of Agile. All of the Agile methods began with the idea that we would have cross-functional and self-organizing teams. And I think if you go to any SAFe or Scrum shop, you'll find out that's the first thing they deleted before adopting. So yeah, right, so you have your tickets, I have mine.
We need to be pragmatic in this case. Anyway, so talking about the engineering practices, one thing I'm hearing from is like the first thing we're missing is like the concept of team, which leads the concept of working together, will lead to the lack of concept of pairing and mobbing because of that.
That's right. So you can't work more closely together than when all the people who are necessary to make the feature work are actually sitting together, either virtually or physically, and doing their parts. So if there's a front end and a back end, having them work together simultaneously. So you're building the API that I need as I realize my need for it. We're both going to deploy together.
Crazy idea, isn't it?
And it's going to work. And usually we save that, at least in American corporations, they save that kind of intelligent work for crisis. So when something's late and it's failing in production, what do? You set up a war room.
That's pretty amazing, because most of the things we preach in Agile world is becoming, it's coming to life when you have a kind of crisis. Most of the companies, they gave out the yearly budgeting processes when we have the 2020, and you had to make a decision on daily basis, and then we're coming back to those ideas back, right? So yeah, you're right. You have a war room happening in the organization, and then people working together.
Yeah, and you get the same thing when there's a thing called scatter gather. So let me set the stage for it. I have 7 features I need done. So we'll have our team lead. But team lead, by the way, doesn't exist in Scrum.
I know. You know.
But anyway.
You guys know.
Yeah, we have a team lead who will do the design, and then they'll divide it up into tickets. So maybe this one is 7 tickets, and this one's 12, and this one's 5. And then we'll assign all those tickets. So we'll assign them all today. Now you have a queue of tickets, and I have a queue of tickets. And your first 2 may be for a different feature than my first 2. And my third one might relate to your feature and into somebody else's. So we each have our own queue with our own priorities, right? So these pieces are getting done. You do a piece, I do a piece. There's no feature. And at some point, somebody gets panicky. Oh my gosh, this isn't going to get done on time. We have 7 or 8 pieces outstanding that haven't been finished. So what do? Is they say, we're going to prioritize. So if you own a piece of this feature, work on only this feature and delay everything else until we get this feature done. And they do that. The manager puts, heat on that one feature, and you get it done and you're deployed, and everybody goes, yay, that really worked. We got it done. That's great. And then we go back to scatter gather again. It's like, why is it only a smart thing to do when you're in a hurry, but you also feel like you're always in a hurry, but you don't always do it? So working together, prioritizing work on one feature, just makes sense.
Yeah, my answer would be to keep people busy, because for you in feature A, you just need to do a small change. I need a big change, so we cannot keep you on the bench for like a few hours or a few days. So you need to be busy with something else, so you get a different feature to work on it. And then we ended up with this one, which leads us to, I believe, other practices, starting with the CI you mentioned.
So CI is just a brilliant idea. Dave Farley gave us a great definition. He said that CI is when every valid change that one of us makes on our own machine reaches everyone else's machine as soon as possible, at least within the same day. So, notice he didn't say that has anything to do with running Jenkins or running a pipeline. CI is a developer behavior, and it means that my changes make it to your machine within minutes or hours.
I love Craig Larman's definition of continuous integration, which means he said continuous integration is not about the machine servers, but it's about the integrating continuously. That's the whole crazy idea. And I think it's like a uncommon definition, by the way, right now.
Yeah, I think most people think that if you have a pipeline, you're doing CI, because they call it a CI server, which, it is a tool to help with CI. It isn't the definition, but it's easier to install a tool than it is to install a behavior.
Yeah, tell me more about managing team this way. Okay, anyway, let's stick to the engineering practices, because we're gonna get a bit on bashing the tools for managing teams in that moment, and I just want to see this one. So we got tools, but we don't integrate continuously, which basically means I'm having my branch for a few days in a optimistic version and for a few months in pessimistic version, but then I integrate and we deploy it, so we call it continuous integration, right?
Yeah, because, something was building it every once in a while. The problem, of course, is that the longer we are away from our main branch, the more we diverge, right? So on Monday, I started, and then I've made a bunch of changes. And maybe I've done local commits, maybe I haven't. Maybe it's just all loose in my development space. That scares me. I need a place that I can go back to in case things go wrong. But maybe I haven't committed at all. Well, in the meantime, a dozen other developers have been pushing changes up to the main branch. Well, now the code on my machine doesn't look like the code in the main branch. And that means we're going to have integration problems. It's most likely that the code is not going to merge cleanly. And even if it did merge, it may not pass all of its tests anymore. We may have system effects that your change and my change don't work well together. But we're not going to know that until we get around to integrating, which might be just before release, which is a nightmare. And it may be that we don't release very often.
That is basically why the integration phase takes so much time, because it's not about integration, but it's about fixing the problem with the integration.
Yeah. And if we were really continuously integrating, we would find that problem as soon as it occurred. We would be in the same main branch. So trunk-based development is an attempt to not delay and therefore magnify our integration debt.
Yeah, and one of the consequences of what you're saying, so you have 12 people, but if you want to have more than 12 people, then it's more complicated. And you get what a customer of mine call it merge festival. So end of the sprint, you have all the people squeezing the changes, and surprise, nothing works. And as a consequence of that, what I notice is you end up with having a team owning a component of the system, so no one else can touch our component of the system, because otherwise like 40 people will be committing to the same part of the system, and we cannot see what is happening, right? So instead of solving this by having a continuous integration, we solve it by having a code ownership in the context like my team, my part of the code, don't touch it.
That's right, and we do see this a lot. That's a very common pattern. Because we defer the integration, it becomes much more expensive. Therefore, we have to carve out time in our schedule to fix it, which is the same way we handle technical debt, right? They squeeze out the time to work on it, and then they figure, well, later on, we'll make a time period where we'll try to fix all of the things that we've just now broken. And of course, you can't.
But the thing with the technical debt, you can always say we will fix it next release. With the integration, you cannot fix it next release, because if it's technical debt, it can still work poorly, but it can. With the integration, it doesn't work, so you cannot fix it next release, basically, right?
Yeah. And sometimes we think that if I don't go to the doctor, then I can't get a bad diagnosis. So if we just put it off, we can avoid the pain. It's like, well, except that putting it off magnifies the pain.
So I mean, stop testing is not to find any bugs.
Yeah. If you don't test, you don't have any bugs.
Yeah. Jerry Weinberg, he said if the code doesn't need to work, then it can meet any other requirements, right? That's the whole idea. Okay, so we mentioned continuous integration. We mentioned pair programming. You also were saying something about the test first or test TDD. So how about this one? Where we are with this one?
So TDD, I think, is pair programming probably had the worst press. It's probably the only XP practice scientifically proven to work by Laurie Williams and others. TDD is probably next online. It's like, no, I'm not going to write the tests because that will slow me down putting my big feature idea in, because I need to write a lot of code that doesn't run for a long time and then debug it until it finally works. And then if I have time left over, I'll write a test. And so the idea that, well, no, we can write a test for something that we want it to do, and then we can grow our code, with safety by locking down some invariants ahead of time. But the problem with TDD is it's too much of a change. And most people can't imagine change, right? You imagine what you have now with an addition or a subtraction. So they imagine that the way they're working now, the kind of code they're writing now, but they're forced to go write a test first. Well, I don't know what my code's looking like, so I can't possibly tell you what test I'm going to write for my code. This is because they can't imagine a change. The way they do it now, they write the code and they look at the code and then they write a test that exercises that code.
So by change, you mean on the practices, on the, mental model level, on the what skills?
This is a universal human thing.
Okay.
Like, for instance, if you talk to a kleptomaniac about not stealing, they imagine the same life they have now, always in trouble with the police, none of their friends trust them. It's a very difficult life with a really serious problem.
Sounds like a life of the developers.
But also without the enjoyment of stealing things. So they only see it as a subtraction. They don't realize that the reason why their life is difficult is the kleptomania. That if they didn't have that, they could have relationships and friends, and they could, be trusted to do better work and probably make better money and have a better life. Likewise, this is the same thing with TDD. They picture what they're doing now plus tests. And that sounds hard. Well, it's not the same thing they're doing now. With TDD, I'm not testing the code. I'm writing down an invariant. So whatever code I write, when I pass it as 7, it should give me back 42, just making up numbers. And if I pass it a 5, it should be 90. Well, there's an algorithm behind that. I've got an algorithm in mind. I've designed it. I've thought it through, right? But I'm just putting down the invariants. And as I do that, I put a little bit of code in that makes that invariant, be true. The test passes, so I know the test is good. Now I can change that code, and anything that gives the same responses is mathematically equivalent, right? So I can make it better performing, worse performing. I can make it prettier, uglier. I can make it more structured or destructured. I can normalize and denormalize, but my tests protect me. And if I make a change and a test doesn't pass, then I know that it's not functionally equivalent. Well, that's what I'm doing with TDD. I'm not writing tests against the code that doesn't exist yet. I'm writing down, what are the requirements that I need to meet. But not being able to picture that, a lot of people get crazy ideas. So recently I had a whole conversation on LinkedIn or X or somewhere, and somebody said, well, TDD is when you write all the tests first. And it's like, well, that could only possibly work on the most trivial and obvious possible coding. And that's what they were saying, is it can't work unless it's really obvious and trivial. Well, yeah, if that was TDD, that would be true. But it's not. That's not how that works at all. So people aren't doing it a lot, and the main reason is because the way the idea has been presented to them, they can't picture it. And it's a thing you have to experience or see done correctly before you can say, oh, of course that makes sense.
So what I'm hearing is we heard about those items, we either modify them to meet our definition, or we just ignore them, or both, right?
Right.
So we talk about CI/CD, we talk about pairing, we talk about TDD. Did we miss any of the main one?
I think those are part of that is working small. And I think that's been a big problem. And when we talk about the problem with, CI, and we talk about the problem with TDD, and we talk about, all these different things, it all comes down to the same idea. User stories came from XP. A lot of people don't know that. They think that user stories are part of Scrum, and they never have been. Nobody ever said in Scrum that you use user stories. That's never been a requirement. But, that came from XP. And the idea is that it's a story that a user would tell about the system as if it had been developed. So, when we've done this, how would people describe that? Would they say, well, when I opened up my map, it showed me where I was and marked 3 of the common locations I visit so that I could just choose those and go there. That would be a helpful feature. So that's the story. Well, interestingly enough, that's not a user task. That's not a build me this thing or that thing. It's not build me a service or a component. It is an end-to-end integration described. And those things are sliced for delivery, not for assignment. So again, working together, if you look at your user story, well, here's a feature I want, and here's a big spec for my feature, right? Well, let's divide this up into pieces to be implemented. Then you're already on the wrong track. What you should be doing is like, well, okay, what is the simplest case of this feature? And then what's the next thing we would add to it to make it better? And what's the most important thing it doesn't do yet, right? And we would plan for value drops or releases or deployments. Sadly, most people in this space, in the Agile space and in the business space in general, have no idea how to do this.
So I think to stress out here, like a iterative development means you're gonna modify the code or the system that is existing, right? So if you're assuming that you're writing the code for the final version, that's not iterative for sure. That might be incremental. And the other thing I'm hearing is like we're still missing those competencies, right? So we today we had a talk by Jenny Jepsen, and we also had conversation for those who haven't seen the conversation. That should be by now on the podcast about those competencies, how we build them. Because one of the things I've observed, and that I mean wrong on my perspective, is that as a manager, I often expect people joining my company to have the right competencies to develop code. And because you're being code engineer, that makes a lot of sense that you know how to code. But what we are saying here is like these competencies are still missing. So how do we build them, and how do we build them safely? Because if the assumption is you should know them already, then no one is gonna say I don't know them, because you're saying they're hard to grasp because people don't understand until they try it. And my observation is people don't want to say we don't know them because that means I'm incompetent, right? How do we build them?
So that is a tough game. So let's take a look at the average developer, right? Let's assume you don't have too large of a company. So maybe a developer knows 5% of the code base they work in. That's pretty good. If in a large company, they'd be lucky to have 1% of that down. They probably work with 3 or 4 languages a day, every day. They probably know less than 30% of that language they work with, of each one. And for each one of those languages, they probably know less than 25% of its standard library. And they probably don't know that much about the domain they're working in.
From the business perspective.
From the business perspective, they probably haven't met a customer yet in real life. They probably have never installed and configured the system, and they've probably never used it to do a job.
Okay, because the user stores a ticket in the system, not the conversation with the user.
Right. So to them, when they think about the system, what they see is source code listings. Right? They're not seeing that there's a person out there trying to solve a problem and that they're helping that person. So if you consider, how little each individual person knows, then you have to think, well, probably they know a number of interesting techniques, but not all of them. And probably with this limited knowledge, if they work solo, they're going to make mistakes at some point, right? I mean, any change they make might be a problem in production. So obviously we have to have code reviews and separate QA, and we have to do all of these things to try to account for the errors that this developer is going to be making because they're working on their own and they only know what they know and they've only learned what they've learned. Well, that's different from we hired somebody, they already know it all, they should go fast. And companies we hear now that they were seeing 6 to 8 months for a developer to come up to speed after they hire them. Wow, that's brutal. That's expensive. Well, what if we just assume that they're joining the team, that they have intelligence, they have some skills, they have some knowledge. If we could make it a standard part of work that we're always learning, continuous learning, then we go a lot faster and we continue to accelerate. Well, how much intelligence is in the team versus the individual? By unteaming the people, by giving them individual assignments, we've made sure that they can't afford to help each other. If I help you with your assignment, mine might slip. Well, I can't afford not to turn in my work because that goes against my annual review. Maybe I should just let you fail. Maybe I'm a good person and I'll try to help you anyway.
I have my task, so I can send you the link, but I cannot sit with you for 8 hours anyway.
That's right. Yeah, we can't spend that time together. We can't afford it. We've been unteamed.
And often what I'm hearing is like we help each other basically means that we can talk for 5 minutes about your problem and I can give you some hints and then I off back to my
You can send me a question in Slack and I can send you an answer back.
Yes, and that's the teamwork for us. Right?
Well, if we're serious about learning our work and learning our code base and having this kind of information, then we have to start thinking about, well, maybe we need to work together. So there are some nice ways to do this. There's an article on the Industrial Logic blog. It's called Swarming with the Swarm Board.
Which you can find under the recording by now, hopefully.
Yes, should appear right here. No.
Okay, we can do that. We can do that.
So in that we talk about a way that we've assigned work to the team rather than to an individual. So here's the work we want the team to do. This is the most important thing. Okay, who do we need to make that happen? Well, people are signing themselves up. They're saying, well, I can do I'm a UX expert or UI expert or a QA expert. I have my part in this story. And people choose to join that story. Maybe some people, it's like, I don't know that part of the system. I want to join this team so I can get exposed to that, and also I can see how the user interface is designed, and also I can see, right? So people, no questions asked, they join that effort, and then it's like, okay, well, what else do we have? Do we have people left over? Okay, what's the next one to do, right? And people join up on the next one, and that's the swarming that we use. And the swarm board just keeps track of, this is an initiative, these are the people doing it. This is an initiative, these are the people doing that. These swarms have permeable boundaries. I can switch whenever I want to. I just drag my name to the new spot. People can see who's working on it. It's all fine. As a result, you get some exposure to the UI, to the UX, to the testing of it, to the coding of it. You see the front end, you see the back end, you see the database, and you start to see, how this all fits together. And that slows you down the first week or so that you're doing it because you're taking in so much new information. It's a little less typing, a lot more learning, but very quickly you're contributing, right? And also you got a bunch of people who know this work. If somebody gets COVID and they're out for a couple of weeks, everybody else continues the work. It's actually a pretty resilient and powerful way of working, and continuous learning is natural.
What you're saying, the whole idea is to grab one item, maybe two, deliver them as quickly, customer-centric feature, deliver them as quickly as possible to production, then grab another one. Crazy idea.
I know, madness, isn't it?
All right, we're running out of time because of the other constraints of the conference, so I'm gonna close us with any other sources you would recommend, except for this blog you mentioned, any other sources you would recommend or any other hints you would recommend to developers or managers who want to try this crazy idea?
Well, of course, Industrial Logic, we teach a lot of workshops and classes, and we do a lot of in-person coaching. So, of course, I would always recommend us.
That will be in links as well.
But also, Dave Farley, I have no relationship with Dave Farley other than I admire his work, has such a wonderful series on YouTube under the Continuous Delivery YouTube channel. And for those who are involved in the software side of them directly, Emily Beisch, again, no business relationship, has a wonderful series of videos on doing TDD correctly and using various technologies to make it work. I can't recommend them highly enough. They're wonderful people with great ideas.
And the bottom line, what I'm hearing is try.
Yeah.
Put 2 weeks aside, try doing one item at the same time, learn from mistakes, build your knowledge, show that you don't know the whole system.
That's right.
All right, thank you very much for this conversation. I love it, and hopefully you will try as well those practices, not just say, well, they are hard to do. Thank you very much.
To learn more, visit procognita.com/getagile.